Hello there and welcome back to another episode where we are continuing from the previous discussion on clock configuration. And by the way, if you are watching this course on YouTube, please do well to subscribe, like the video, and help me grow this channel. So when I ended the last episode, I realized that I misspelled this. So instead of RCC HCLK, I wrote RCC HCKL, and so the code was not compiling. So I have already fixed that. Just change it from HCKL to HCLK. All right, that was the mistake I saw. Okay, so our clock configuration is done. We have turned on HSC. We have set it as the clock source for SYSCLK, and we have set the dividers properly. So this is where we stand in the clock tree. We expect that since HSC on my board is running at 8 megahertz and the prescalers are all set to 1.1, every other clock engine and every other peripheral connected to them is going to run at 8 megahertz. So let's confirm that. In order to confirm that, after we have called the system clock config function here, I am using these functions that are available in the HAL library to read the various frequencies, like frequencies of the various clock engines. So I'm starting by reading SysClock, and then I'll read HCLK, which is the high speed for the high speed peripherals, PCLK1 and PCLK2. So if we go to the diagram, I'm essentially reading this frequency, these, and these. And because a lot more things are connected, they are all going to run at the same frequency. And the way I'm going to do that is you compile the code first. And this code, you've seen it, right? In the previous episode, I wrote it for us to read the SysClock running on HSI. So it's similar APIs. So this has built, and then I click on debug here. This comes up because I clicked stuff in the IOC and it's expecting to generate code, but we don't do anything with code generator in this course. We just leverage it when it is convenient to understand things, and then we write the code manually. Alrighty then, so it's in debug mode. Main has executed and the breakpoint has been placed on system clock config. This means that system clock config has not even run. To run it, I'm going to click on step over. I still have in mind an episode that will be dedicated to debugging, but I need to do this so that we can see these values. So I'm going to click step over. What it does is going to execute every code in the system clock config function, and then now it comes to the next line. So here we are reading SysTick. It hasn't run yet. When you see the breakpoint there, it means that is the next instruction that will run when you click on the step over. So I click on step over, and voila, you can see that SysClock config is running at 8 megahertz, just as we expect. And then let's check HCLK, boom, 8 megahertz. Let's check PCLK1, boom, 8 megahertz. Let's check PCLK2, boom, 8 megahertz. This, ladies and gentlemen, is how you manually write code that configures your clock source and puts you in control of the speed at which your microcontroller and all the other peripherals connected on it work. I believe this has been useful. If you are on YouTube, please do well to subscribe, like this video, turn on the notification so that when I release new videos, you get to see. Thank you once again, and I will see you in the next video.